Oh, good morning. I miss you guys. Okay, we are going to do multiplying vectors today. So this corresponds with where we left off before the school shut down. So we're going to just pick up where we left off. So this is 8-A4. And we're going to talk about dot product today. So dot product is one way to multiply vectors. Sometimes it's also called inner product. Occasionally scalar product, because your answer will be a scalar or a number also. So all of those, it's the same thing as the dot product. And like I said, it represents a number. So you'll get a number instead of a vector. Okay, so it represents a number. Okay, so if we say A, vector A, dot vector B, that's equivalent to the magnitude of A times the magnitude of B times cosine of the angle between the vectors. So yeah, and be sure and use the right, we don't usually say vector A multiplied times vector B. This you would actually say A dot B. So that's how you would say that. Okay, so let me see if I can kind of explain what this means. So let's say you have these two vectors, vector A and vector B. Okay, so what the dot product is the projection of A onto B. So you've got two vectors going in different directions. You've got a certain angle between them. And what this gives us is if we do this, you'll notice this distance here, from here to here, is the magnitude of A cosine theta, right? I just drew that right triangle. So this is A cosine theta. So they call this often the projection of it. So this is the value of A cosine theta, and then we're going to multiply it by the value of B, or the magnitude of B. So the main application of this, remember when we did work a couple days ago? Well, work, so this is maybe our physics application. So work is equal to force times distance, right? Well, in all of our, sorry you guys can't see that. In all of our work that we did, our force was in the exact same direction as the distance, right? We were pulling straight up, and our distance was straight up. But oftentimes, these are two different vectors. So work would be force, the vector, whatever vector that was, dot the distance. So that's the biggest physics application for dot product. So that might be something to keep in mind for when you get to physics. But our problems are going to be just straightforward. We're actually not going to use this formula in our homework tonight, but I do want you to kind of remember it because it's the essence of our dot product here. And just remember, theta is the cosine, or theta's not the cosine. Theta is the angle equals the angle between the two vectors. Okay. All right, so let's do, on our homework tonight, we're going to do dot product with components. So we're not going to have the angle. So dot product with components. So let's say our angle, or our vector A has an x distance, right? And a y component. And vector B has a B, has an x component and a y component. Then A dot B is going to equal the two x components multiplied together and then added the two y components. What if it was 3 dimensions? Exactly the same, we just have a z component, right? So if you've got A is xa, ya, and za, and then you'll have a b, xyz, right? Then it's the same process. You're going to multiply the x's, the y's, and the z's, and then sum them. So xa times xb plus ya times yb plus z times zb. Okay, fairly straightforward, right? So if you get a dot product that is 0, so if your dot product is 0, what the heck does that mean? If your dot product equals 0, go back to this one. When is cosine 0? Think of that unit circle, right? Cosine of 0 is at 90 degrees, right? So that means there's no projection of A onto B, right? It's going like this. So if your dot product ends up being 0, you know that your vectors are perpendicular. Okay, let's do a quick example. Okay, I'm running out of a space here. Example 1. And this is like number 4 on your homework. So 1 through 3 on your homework is review, and I'm going to put the old notes from, of all of chapter 8 up, so you guys can kind of go back and look if you've forgotten how to do anything. And then number 4 starts with this, the dot product, and the worksheet calls it the inner product, but that's what it's saying it wants us to do. So let's say we've got a vector A, -3, 1, 1, and vector B is 2, 8, -2. Okay, and we just want to find the inner product or the dot product, which is A dot B. So we're going to take -3 times 2, the two x components, and we're going to add that to the y components, 1 times 8, and then add that to the z components, 1 times -2. Okay, and we're just going to add that up. -6 plus 8 minus 2. And lo and behold, we get 0. And so what does that mean? We can say yes. Answer the question on the homework. Yes, these two vectors are perpendicular. Yes, A is perpendicular to B. Okay. All right, guys. I'll see you in the next video for cross product. All right. Thanks, guys. Bye.